But let's get back to your experiment. When you put it in the plastic cube, it becomes a payload. But it just can't be crammed in the cube any which way. The experimental components must fit together, and this is called a configuration. But now we need to stop again and reflect on the conditions our payload experiences during the ConOps. We know at launch the rocket pulls or experiences 20 Gs of force. That means that as the rocket is accelerating forward at a high velocity, it will feel like 20 times the mass of the cube is pushing down on it. We know that the mass of the cube is 64 grams. Therefore, the amount of force exerted on the cube is 1,280 grams. That is nearly 1.3 kilograms pushing down on the cube at launch. And don't forget, there's a whole lot of shaking going on during the launch as well. There is also a force of the rocket hitting the ocean to think about, and the wear and tear from being tossed about at the airport, to being bounced about in the back of a truck, and to being exposed to over 95 degrees Celsius or 200 degree Fahrenheit temperatures in the nose cone while whizzing through the atmosphere. Now you can visualize your thinking and see that there are many hazardous conditions that will affect your payload. So you have some thinking to do to construct a brilliant idea of how to protect your awesome payload from all of those hazards. And this is where the engineering design process is applied. Think about the requirements, constraints, and instructions provided to you to guide your payload design. Remember, the experiment must fit inside the cube. Its total mass should be exactly 64 grams. Also, it must survive the transit process of getting to the launch site, so padding and cushioning will be very important. But what if the experiment does not weigh 64 grams? The solution? Add mass. This is called ballasting your payload. The ballast material can be a number of things. Coins, lead tape, rice, salt, or sand are all options for adding mass. Just be careful they do not interfere with your experiment. So you need to start sketching design ideas and recording your thoughts, making calculations, researching, starting to create diagrams to scale, making models and prototypes to see if they work, and managing your time. Whew, that's a lot to think about and do, but you can do it. So remember, the total mass of your payload must be exactly 64 grams, and the total mass is defined as the mass of the plastic cube plus the mass of the experiment plus the mass of the packing materials used to protect the experiment plus the mass of the ballast if one is needed. It's just that simple to meet the mass requirement. On behalf of Cubes in Space, an iDoodle learning program, we wish you the best of luck and can't wait to receive your awesome experiments.